Okay, endocrine system. I got no idea. Okay, so we'll be looking at homeostasis. So at the end, you should be able to take a couple of questions on homeostasis. Okay, so to begin with, that's just somewhat of a conceptual summary of everything that we're going to be covering, based on the cognitive levels and so on and so forth. So to begin with, homeostasis is all about balance. Okay, it's all about finding a constant level that you have to continuously maintain in the body. Okay, when we're talking homeostasis, we are specifically looking at the endocrine system, not the nervous system. Remember, the endocrine system deals with hormones only, whereby hormones are chemical messengers, and those chemical messengers are transported by some sort of a transporting mechanism. In this case, it will be the blood. Okay, so homeostasis is all about us using these hormones in order to maintain a state of balance within the body. Okay, so by definition, they say homeostasis is a process of maintaining a constant internal environment with narrow limits despite changes that take place internally and externally. As I've mentioned, it's all about finding balance at some case in point, whether it is a balance in temperature, in water levels, or whatever. It's all about finding a state of balance. And then these conditions, they have to be detected in one way or the other within the body. So once they are detected by tissues or internal organs or internal receptors or whatever it is, it has to signal the brain, and the brain has to figure out a response, and that response that it gets to maintain that specific constant temperature, that's what we call a negative feedback. Okay, so what we get is a negative feedback. When we're getting back into our state of balance, that is the negative feedback we're talking about. So the specific type of processes that you will need to know in this case in point is the maintaining of glucose levels, carbon dioxide levels, water levels, and salts. Okay, now these are the ones you need to be able to know off by heart for your exam. Not quite sure which one would come out, could be any, but it is best to prepare for all scenarios and all cases. Okay, and then there are these words which sound defeating: sweating, vasodilation, and vasoconstriction. That's a lot of vasos, but those are some of the words that you do need to know, and it does help, but we are going to go through them one by one. Starting off with the concept, the background concept. As I've mentioned, homeostasis is all about finding the state of balance despite the changes in the environment that may try to break the balance. The body must be able to use these hormones that we are going to go through to find the state of balance again. Okay, so these changes can be either internal or external. For example, internal can be the loss of water levels in the body and so on. External levels could be heat from the outside. The body should find a way in order for it to reach that specific temperature that it was in. Okay, so this internal environment and everything, it's all controlled by hormones. Okay, anyways, so they were saying the internal environment refers to the blood and tissue fluid that surrounds the cells of the body. Okay, so if there's any change in those things, we are going to be detecting those changes. Okay, and then finding our state of balance from those changes. Okay, and negative feedback, remember, the negative feedback is the response. Okay, negative feedback mechanism operates in the human body to detect changes of imbalance in the internal environment to restore the balance. Okay, so when we now getting back that balance, that's our negative feedback. Okay, and that's why they mean there by the way of negative feedback mechanism. All right, so here okay, so O2 and CO2 levels in the blood. We've heard of this one. This is more of a situation where we're breathing, kinda, right? You breathe in the oxygen and breathe out the carbon dioxide. If you're a plant, you do the same thing in reverse. Okay, and this is one of the things where you're looking at the maintenance of the carbon dioxide levels within the body. Okay, and then we can maintain blood glucose levels. There's a hormone for that. osmoregulation. Osmo means water, so osmoregulation is all about maintaining the levels of water. Now if you maintaining water levels, it's in conjunction with salt, because if you try to think about it, if you have high salt levels, it's because you have low water levels. Okay, so if you're cooking, for instance, and you have a lot of salt in your food, in order for you to bring back that right taste, what you will do is basically add more water. So the body does the same thing. So in order for you to maintain those salt levels, it would have you feel thirsty all over again in order for you to drink up the water and then get back that balance that you need. Okay, and then the hormone levels in the blood, these are the ones that are the masterminds of everything. These are the ones that are performing the communication between hormones and everything. So they are the ones that are getting us the balance that we are talking about. And then there is thermoregulation, or thermo for thermal heat, temperature. Okay, so it's all about maintaining the temperature, and the way in which we do this, you already know. A good example is sweating. Sweating is one of them. Even the need of water could be one of them, and the good example you saw of vasodilation and vasoconstriction is one of them. So we're going to go through these hormones one by one. There is a very long list of hormones. Let me just get the list out for these hormones. So each hormone has to be released from a certain endocrine gland. Okay, so a specific endocrine gland has to secrete a specific hormone, but this hormone must be targeted to a specific organ. So if we, let me see if I can get a white area or something. Okay, so a specific hormone must be targeted to an organ, and then this organ must do a certain task. Okay, so a couple of hormones that we already know is the famous hormone known to men called testosterone. So testosterone has one job, which is the secondary sex characteristics in males. Okay, it is secreted from a specific organ, and the name of that organ is the testicles. We have to know that it is from the testicles. So it is from the testicles, and it is targeted to a number of stuff in there. So the heart, the brain, basically it goes through all over the body, because this is the only hormone that we have. So this testosterone is to bring out those sexual characteristics in males, sexual activity and so on and so forth. It is brought out by that testosterone. Okay, then there is other hormones as well that we have to know. Okay, there's a long list, a very long list. Okay, okay. Where are you? Okay. Okay, beautiful. Okay. List acquired. So, starting off, growth hormone. The growth hormone, GH. Okay. So, quick hack though. There is a number of hormones that are written abbreviated. They are written in short. So by them being written in short, we know that a number of those hormones that are written in short come from the master gland, which is the pituitary gland. Okay, somewhere near the hippocampus. So that pituitary gland is secreting a number of those hormones which we are able to write in short form, growth hormone being one of them. So what that growth hormone does is that it brings basically the cellular growth, bones, muscles in the human body and so forth. So this brings what we mean by the cellular growth. So cellular growth, muscles, and a couple of those other things that that come with it. And then we've got one called TSH. Okay, see that it's also written in short, also from the pituitary gland. So TSH stands for the thyroid stimulating hormone. So now this is the situation. What we do know at this point in time is that we should have a certain endocrine gland that must secrete a hormone targeted to a specific organ. But TSH is a little different, because what happens is it will be secreted from an endocrine gland to another endocrine gland to secrete a hormone. So this is more of a chain on a chain. So this thyroid stimulating hormone is secreted from the hypothalamus, from the pituitary gland into the bloodstream, and it is targeted to the thyroid gland. Okay, so what it does is it stimulates the thyroid gland. And what the thyroid gland would then do is that it would start secreting a hormone of its own. Okay, so then let's talk about this thyroid gland a little bit. So this thyroid gland has its own hormone, confusing a bit, called thyroxine. Okay, so don't worry, thyroxine does not stimulate another endocrine gland, so that's just the end of the chain. So this thyroxine has its own functions of its own. So what this thyroxine does is that it brings the metabolic growth of the somatic cells, the body cells. It brings the metabolic growth. Okay, fat cells, high thyroxine. Think about it in that way. Fat people, high thyroxine, if you want to put it like that, but it kind of sounds quite discriminating. But it brings them that metabolic growth that we are talking about. And then one which is similar to, which we are quite familiar with, is FSH, the follicle stimulating hormone. So if you remember your ovarian cycle and your uterine cycle, or rather your entire menstrual cycle, you should be quite familiar with the FSH. We know that before the ovulation, we need the FSH to stimulate our follicles to become our Graafian follicles, which will then contain the ovum that we really need for that ovulation process. So that FSH, note it's also written in short, so that FSH also comes from the pituitary gland. So from the pituitary gland into the bloodstream, and then right into the ovaries, and those ovaries would perform that stimulating of those follicles to become those Graafian follicles. Alright, so that is our FSH. Keep in mind it is written in short, so yes, it is from the pituitary gland. Okay, and then we've got prolactin. So prolactin, so to be quite familiar with this word, lactin, from basically the word lactose, we know this as milk. Someone who's lactose intolerant can't drink milk without having a fever or something like that. So prolactin has to do with the mammary glands in females. So this stimulates that milk production in females after basically induced labor and all of that. So this comes from the hypothalamus, targeted to the mammary glands, aka the boobs, the tits, however you want to call it, the mammary glands, to secrete that prolactin that we are looking for. Okay, all right. And then another one we are familiar with is LH. Note, it is written in short, so it is from the pituitary gland. Okay, so the LH stands for the luteinizing hormone. So this is what brought forth the luteal phase of the menstrual cycle. Remember, one of the phases was the luteal phase, and in the luteal phase, this is where we brought the development of the corpus luteum. This was after ovulation, where we had our follicle, and basically it would rupture, okay, and then an ovum would leave that follicle. It would then leave, and what would remain would then be processed to become a corpus luteum. And what brought up that entire change in transition was this luteinizing hormone that we are looking at here. And remember, it is written in short, so yes, it is from the pituitary gland, which is our master gland. And then we've got adrenaline. Okay, so adrenaline is from the adrenal gland, which is somewhere there near the kidney or something, I don't know, near the liver, not the kidney, weird. Okay, so this adrenaline brings the fight or flight response. Okay, fight or flight. So in times of fear, you're either going to fly away or fight, between those two. So it brings out that response, and the way in which that it brings this response is that it will cause those two words we spoke about earlier, which was the vasodilation and the vasoconstriction. Vasodilation is basically when your blood vessels become dilated, they become more open to allow easy flow of blood. Okay, that was one of them. And then there's vasoconstriction, where rather when from them being dilated, they are rather constricted. Okay, this is the normal form in which that you are in, but if this adrenaline goes high, then it becomes dilated to allow this blood flow to flow more freely and quickly. Okay, so the reason it is like this is because of that fight or flight response. If you really want to run away, you need to get more blood into those muscles in your legs, your heart, and so on and so forth. Okay, and then we've got a complicated hormone called ADH. Okay, now ADH is reason I said it is complicated is because it is written in short, but the problem now is that it is not from the pituitary gland, but rather this is from the hypothalamus. And this ADH stands for antidiuretic hormone. Note, antidiuretic, uretic from urine, and when you urinate, you're basically controlling water levels. So this antidiuretic hormone, all it does is it has the job of maintaining the water levels within the body. Okay, how it does that is something that we are going to look at when we start looking deeper into osmoregulation. Okay, and then we've got oxytocin. So oxytocin is one of the cute hormones in females. So what this oxytocin does is that it helps to bring those labor contractions, okay, after the gestation period in females. So it brings those contractions in the uterus, okay, to allow the kid to come out because the time has come. So it brings those labor contractions, okay, during that childbirth. All right, so with this in mind, we're now going to look at those examples of the negative feedback mechanisms. So what we have here is a template of how the negative feedback mechanism is supposed to be. So out of those 7 steps, all of them should contain at least these 7 steps. So number 1, there has to be an imbalance that is detected. Okay, once an imbalance is detected, okay, then a certain center of control has to be stimulated, meaning either we're either going to put in a hormone or remove a hormone, between those two. Okay, and then the control center must respond. Okay, so what do we mean by the control center? Well, right, control center. Okay, and then a message must be sent to the target organ. Okay, and then the target organ must do something. Okay, either stop working or work more, between those two. Okay, so if you want to put this into a more applicable manner, you can say that as a manager, if you notice that you are making very little money in the business, you would go and shout at the workers and the workers would work faster and then you get more money. That's a cute example of how that works. Okay, so then the target organs, which is the workers, they'll be giving the response which is working faster or working more efficiently in that manner. Okay, then we're either going to be opposing or reversing an imbalance. Okay, and then in that way we'll restore a balance. Okay, so we're going to start off with glucose levels. Okay, so before we look at these glucose levels, let's do a bit of a background from our grade 11 knowledge. Okay, so from our grade 11 knowledge, we remember the lever. That's a weird looking lever, but suppose, imagine I drew a proper lever. Okay, so imagine that is a lever. Okay, so this glucose of ours, this glucose of ours must be stored. Okay, this glucose that we have in the body is stored in the liver, and it is not stored as glucose, but it is stored in glycogen. It is stored as glycogen. So note, glycogen is stored glucose. Glycogen is stored glucose. Okay, so glycogen is stored glucose. So you chow up your glucose, your sugar, you drink like 7 tablespoons of tea, and your liver has to do the job. Okay, it has to perform that conversion and store up that glucose. Okay, so that it brings that necessary level. Okay, so in detail, so remember, first we have to detect an imbalance. So the glucose levels in the blood increase above normal. So in this example, we have too much glucose within the body, too much sugar. Okay, so then the pancreas will be stimulated. So sure, you can note that the pancreas has to do with the decrease. Okay, so the pancreas is what's going to bring the decrease. Okay, so the pancreas is the one that's going to be stimulated. Okay, so it's going to be stimulated to bring out the hormone insulin. That's our superhero. Okay, so it's going to bring insulin into the blood. So this insulin is going to travel to our uncle liver there, and it's going to be like, yo, liver, you know what, we got a lot of sugar in here, so do something about it. Okay, and then the liver is going to be like, okay, cool, so this is what I'll do. Since we've got a lot of sugar here, we're going to take it to the bank. And what the bank really is just that it's glycogen, basically. So insulin travels into the blood to the liver, and then it will stimulate the conversion of the excess glucose to glycogen. Okay, and then it is stored in that liver. Okay, and then the glucose levels in the blood will now decrease, and then the balance will be brought back. Okay, so let's see what really happened. So we detected high glucose. Okay, remember there is a control center. In this case, our control center is our pancreas. Our pancreas is going to be stimulated, and this pancreas is going to secrete the hormone insulin. Insulin inhibits, okay, it inhibits glucose. So this insulin will go to uncle liver, okay, and liver will store glucose. And how does it store glucose? Well, it just converts it into glycogen and puts it into itself, which is, well, into the liver. Okay, so question is, what if it's low? Well, if it is low, the opposite happens. But this, in this case in point, is now that we'll have a different hormone that is not insulin, because remember, insulin has to bring decrease rather than an increase. Okay, so once again we are going to detect it. So the glucose levels in the blood is below normal. Okay, so the pancreas, which is the control center, is going to be stimulated. So when it is stimulated, it will secrete the hormone. In this case, it is glucagon. Okay, this will be secreted into the blood, and then from the blood it will go to our liver. Okay, so while it's in the liver, it will stimulate that liver, and it will be like, yo, liver, you know what, we don't have much sugar in here, man, can you, like, you know, turn up the heat a bit, you know. And then it will go to the bank, you know, savings account, and if it goes to the savings account, it will meet the glucose. It will break down that glycogen, and then it will bring back the glucose that we need. And then in this case, our glucose levels in the blood will then increase, and then that normality will be brought back, which is our negative feedback. All right, so now that is a visual representation. So two cases, it's either high or low, so either way there is a response. Okay, and then now there is this CO2. Okay, so now we're going to be regulating carbon dioxide levels within the blood. So here, remember, first you must detect it and then go to the control center. So we're going to detect that CO2 levels in the blood are above normal. Okay, there's too much carbon dioxide. All right, so these receptor cells in the carotid artery, okay, in the neck, they're going to be stimulated. I tell you, you'll breathe. Okay, kind of. So they're going to be stimulated, and this will send impulses to the medulla oblongata, the brain, somewhere around there. So that's our control center, and the medulla oblongata is going to stimulate the breathing muscles. Okay, the diaphragm. If you remember this from grade 11, remember that the diaphragm is somewhere right below the lungs. Okay, it goes opposite as the lungs. Okay, if they inhale, it goes outwards. If they exhale, it goes inwards, in that manner. So the medulla oblongata will then stimulate these muscles, so the intercostal muscles and the diaphragm, to contract more. Okay, so they contract more intensively, they increase the rate. They're basically doing their job faster. It's like an angry manager at this point. Okay, and then more CO2 will be taken out of the lungs in this case, and then you will bring back that normality. Okay, and then we've got osmoregulation. Remember, osmo meaning water, so we are maintaining water levels. Okay, so remember, this is done by the ADH, the antidiuretic hormone. So when you are regulating these water levels, you are also regulating salt levels in the opposite manner. Okay, so firstly, we're going to detect something. We always have to detect water levels. All right, so suppose you've got low water levels. Okay, so which means we're going there. Okay, so the water levels, they drop below normal, so the hypothalamus will detect high concentration of solutions in blood. Okay, solutes, what do we mean by solutes? Well, solutes are, it's the salt that we're talking about, because remember, a solution is made up by a solute and a solvent. Solute being, well, salt, solvent being the water, the osmo that we're talking about. So it will detect those higher concentrations. Okay, and the hypothalamus will create the feeling of thirst. Okay, you will begin to salivate and so on and so forth. So you'll have that feeling of thirst, and well, what do you do when you're salty? Well, then you will start drinking up more water. Okay, and because of that is because of the ADH that was secreted by that hypothalamus. So now suppose the opposite is done. Okay, our water levels are above normal. Okay, we've got too much of them. So first, they're going to detect a low concentration of solutes, or rather a high concentration of solvents. Okay, and then it will start secreting less ADH. Okay, and because of that, you're going to then start to reabsorb less. Remember, the kidney has to do with that absorbing of water. Okay, so it will absorb less. It will be like, you know what, no, we're full, we don't want more water, so you guys go on. And when it does really go on, then you'll continue to pee, basically, and it will bring out that as your negative response. And that's how you would maintain those water levels. You'd release that excess water as urine, hence the name states, the antidiuretic hormone. Okay, so that's literally what I said. Weird. And the salt levels in that manner, it's the same thing. When you are regulating those salt levels, there we go. So the salt levels in the blood increases, so you have to detect a change, as I've mentioned before. Your receptor cells in the afferent and efferent arteriole of the kidney must detect the high levels of salt. Remember, everything has to pass through that kidney, because what the kidney does is that it's a filtration system. If you remember this from grade 11, it filters all those liquids and everything within the body. Okay, so it will detect these high levels of salt, and then the adrenal gland will be stimulated to stop secreting aldosterone. Okay, aldosterone, salt guy. Okay, it will stop secreting this aldosterone. Okay, and then this will decrease the reabsorption of those sodium ions. Well, it just means salts. Okay, it will just tell the kidney, listen, take less of these salts. We've got too much of them. That's exactly what's going to happen. So when we have less of those aldosterones, that's the response we would get, and then the salt in the blood vessels would decrease, and then you would get back your normality. Remember, it's all about finding the balance. And if it is low, the opposite happens as well. So first we detect the change, okay, and then we go to the control center, kidney, okay, which will get that low salt levels signal, and then the adrenal gland will be stimulated to secrete more aldosterone this time. Remember, when we had high, we secreted less aldosterone. This time we are secreting more aldosterone. Okay, so it will start secreting more aldosterone, and this will increase a reabsorption of sodium ion, salt. Don't let that confuse you. It's just Na. Those who do chemistry, they know this a bit better. Okay, so it will increase the reabsorption of these sodium ions from the renal tubules. If you remember the structure of the kidney, those seminiferous tubules. Okay, so it will bring up that reabsorption, and because of that we get more salt levels within the blood, and then you get back your normality. Cute stuff. So that's the negative feedback mechanism of salt. That's just another graphical representation. And then the same thing goes with thermoregulation. So on a hot day, the hypothalamus is stimulated to send impulse to your blood vessels. It will cause your blood vessels to dilate, to become more wider. Okay, so which means that they are able to pass through your skin. Okay, because remember, these blood vessels are pretty much everywhere, so they will also then get to your skin. When they reach that epidermis of your skin, they get heated, they get lighter, and then you sweat. Okay, that's basically what happens within those sweat glands that we have there. Okay, and the opposite happens as well. So when it's like this, instead of them dilating, but now they are rather constricting. Remember, vasodilation and vasoconstriction are your biological terms. So rather they are going to constrict, and you'll also notice that some of the hairs on your skin will begin to stand like meerkats or cats on cocaine. So they would stand to cover the surface of your skin, and you'd see those as goosebumps. Okay, and that would prevent any water loss in that manner, right? And that is your balance in terms of temperature. And there were the two words that I was talking about, vasodilation and vasoconstriction. Dilation meaning that they decrease in diameter, dilation, and then a normal one would be something like that. And if they constrict, they're going to decrease in terms of the diameter that we are talking about. Okay, and they would control the blood flow in that manner. And temperature, that was thermoregulation that we just did. That was the sweating and the shivering and goosebumps that we spoke about. Alright, and there we have an activity. So they're saying name the heat regulation center in the brain. I honestly have no idea. What happens to the blood vessels of the skin on a cold day? I honestly have no idea. Describe how the state of blood vessels mentioned in question 2 decreases heat loss. I have no idea. What happens to blood vessels of the skin on a hot day? I have no idea. Describe how the state of blood vessels mentioned. I have no idea. I did not know the answers were there. But, oh yeah. And we've got a structure of the skin. Okay. Mammalian skin, which just means, well, skin from a mammal. It's got an epidermis, sweat glands, sweat pores, and blood vessels, afferent and efferent, and so on and so forth. And you're asked to label A, B, and C. B should be a sweat gland, C should be a blood vessel. I've got absolutely no idea where A is, so I'm guessing A should be there. Sweat pause. I'm feeling kind of smart. Sweat pause. Describe how I've got absolutely no idea. And that's the end of the presentation. This was cool.